Hi guys, welcome again. This is Rafiat from Octet Academy again. Last video we talked about Dalton's atomic theory, what it contributes to our understanding of what atoms and matter is generally. This is a 2022 WAEC past question on Dalton's atomic theory. It has 3 questions. It's a theory question as well, so it carries a bit of mark too. The first question is that you should state 3 postulates of Dalton's atomic theory. We listed all 5 in the previous video, so you can just check the previous video for postulates of the Dalton's atomic theory. Also state that to list 2 limitations of this theory. And question 3 is explain why the following statement from Dalton's atomic theory were modified. So I'm going to be answering just question 3. Reason being that, let's even say we've not talked about Dalton's theory before, so question 1 we already dealt with that in the previous video, so there's no point repeating that here. So you can just go to the previous video to get what the theories are. And even if at the point of being examined you don't know anything about Dalton's theory, this question I believe already offers you some of the answers that you need. So it gave 4 statements and it's asking you explain why the following Dalton's atomic theory were modified. So invariably what that tells you is that the statements that were given to you are actually part of the atomic theory. So I've written the statements that were given in the question in blue and the modifications in red. So let's even say you don't know any Dalton atomic theory. All you just need is paraphrase this 4 that has been given to you, and you already have 3 postulates of the Dalton's atomic theory. Even let's say you did not learn anything about that before you got to the exam hall. So this question already gives some of the answer as part of the question. So explain why the following statements were modified. The first one is that all elements are made up of small indivisible particles called atoms. The discovery of protons, electrons, and that they do contain smaller subatomic particles known as protons, electrons, and neutrons. So that made it necessary to modify these 4 statements. The second one is that atoms combine in small whole numbers to form compounds. The generation of or the synthesis of large organic molecules, example polymers, makes us know that atoms do not necessarily have to combine in small whole numbers, and that atoms are indeed capable of combining in large numbers, and that atoms of the same element are alike in every aspect. The discovery of isotopes let us know that that is not necessarily the case with a number of atoms. That elements that exhibit isotopy do not have all of the isotopes to be exactly the same. Example is hydrogen. So you have hydrogen, the one that is most common, and here you have deuterium, you have tritium, oxygen exhibits isotopy too, chlorine exhibits isotopy, and this means that atoms of the same element can actually be different if you have isotopes of the same element. And then atoms can neither be created nor destroyed. The discovery and application of nuclear reactions make us understand that atoms can be created and can be destroyed, as a lot of nuclear reactions involve the destruction and creation of atoms. I hope you find this useful. Don't forget to like, follow, and share. And if you have any questions, leave that in the comments.